So the problem is we are given an array and we have to sort the given array, and the given array has only three types of value. It can have only 0 or 1 or 2. We might have given an array of form like this. So we have to sort this given array so that all the zeros come first, then all ones, and in the end we have all the 2's that are present in the given array. One naive method which comes up to our mind the very first time is we can sort our array. Sorting the array. If I apply any sorting algorithm to my given array, this will take all the zeros at first, then ones, and in the end I get all the 2's. And what is the worst time complexity of sorting algorithm? That is O of n log n. But the expected complexity given in the problem is big O of n. We have to optimize our code to the time complexity big O of n. So surely we cannot apply any sorting algorithm to our problem. Also, we can also observe that in the given problem we have given only three types of value: zeros, ones, or 2's. If the examiner wants you to do in this big O of n, that's why he has given these peculiar values. Otherwise the problem would have been of a sorting algorithm. So what we can do more better in our problem? So another method number 2 comes into our mind is, okay, so we have to do it in a big O of n operation. So we can only linearly traverse in our array. So what we can do is, I will prepare a temporary array. Let's say I prepare a temporary array. Let's say I prepare a vector of integer array temp. So I have prepared a temporary array initially which is empty. Now what I'll do, I traverse left to right in my original array. Okay, let's say I have this array 0 1 0 0 2 2 0 1 1. So here I have to traverse from left to right, and what I'll do, whenever I see 0, I push those 0 in my temporary array. After that I again traverse my array, and whenever I see ones, I push those ones in my temporary array. And after then I do a third traversal, in that I push 2's in my array. So here I am doing 3 traversals. So here I am doing 3 traversals in my array. So let's say this is my temporary array and this is my original array. So what I do, I'll traverse from left to right. I can say I traverse ARR from I is equal to 0 to n minus 1. So here I saw 0, I will push this 0 in my temp. Here I see 1, I will discard this 1. When I saw 0, I will push that 0 in my temporary array. When I again saw 0, I push that 0 in my temporary array. I saw 2, I will do nothing. I saw 0, I push that in my temporary array. I saw 0, I push that in my temporary array, and so on. After that, I'll do third traversal. This was my first traversal. After that, I'll do third traversal from I equal to 0 to n minus 1. In the third case, whenever I see ARR I equal to 1, I will push that in my temporary array. So here I can I traverse and I saw 0, I'll do nothing. I saw 1, I push it in my temporary array. I saw 0, I'll do nothing. 0, do nothing. 2, do nothing. 1, 0, do nothing. 0, do nothing. Then I again see 1, I'll push that 1. So whenever I see ARR equal to 1, I push that value in my temporary array. Then I do third traversal from I equal to 0 to n minus 1. In the third traversal, I see 0, I do nothing. I 1, do nothing. 0, do nothing. 0, do nothing. Whenever I see 2, I push 2. Whenever I see 0, do nothing. 0, do nothing. 1, do nothing. So in the end, what I'll see that my temporary array have all the value in sorted manner. So this is my answer, and I can return temporary array as my answer. Now what is the time complexity here? So we know that in each loop we are traversing linearly from I0 to n minus 1. So each loop have time complexity big O of n, and we are traversing 3 different loop, one after another. So big O of n plus big O of n plus big O of n. Overall it will be big O of n time complexity. But here we have used an extra memory space as a temp array. So we can say that we have reduced the time complexity from n log n to big O of n, but we have increased the auxiliary space to big O of n as well, because I am keeping a temporary array which is of the size of input. So can we do much better? Can we do more better? So can I reduce the time complexity and still have the time? Can I reduce this auxiliary space and still have the time complexity big O of n? Yes, I can. So there is a method 3, which is the most efficient method for this problem. In this method, we have time complexity big O of n and the auxiliary space big O of 1. This is my time complexity and this is my auxiliary space. So what is this method? So if you are familiar with quicksort algorithm, in the quicksort algorithm, we learn about partition algorithm. We partition a given array around a pivot, and those partition algorithm are Lomuto partition and Hover's partition. These two are the partition algorithm which works on big O of n time and big O of 1 space. Both of them work on big O of 1 time complexity and big O of 1 auxiliary space. But in those partition algorithm, we partition our given array around a single pivot only. So let's say in a given array we have a pivot x. We choose in Lomuto, we choose the last element as pivot. In Hover partition, we choose first element as pivot. So all the values which are less than x come in the front of my array, and all the values which are greater than x come in the end of my array. So in that way I partition my array around the pivot x. So how will that help me in the given problem? Actually, over partition can't help, but there is a similar algorithm which is the advanced version of these partition algorithm, and that algorithm is Dutch national flag algorithm. Dutch national flag algorithm. What this algorithm do is it separates three types of values. So here we have given zeros, ones and twos. Instead of that, we might have given three types of ranges as well. Let's say there is a range 1 which is from 1 to 10, and there is a range 2 which is from 11 to 20, and range 3 which is from 21 to 50. And the question would have asked us that in the given array which have the positive integer values, place all the values which are from 1 to 10 in the front of my array. All the values which belongs to this range 1, put them in the front of my array. All the values which belongs to 11 to 20, put them in the middle of my array, and all the numbers which belongs to this range, put them in the end of my array. This given problem and this problem are similar. This is the harder version of the given problem. So how this Dutch national flag algorithm actually segregates these three types of ranges or three types of values in my given array. So let me dry run it for you for a given example. Let's say the given array is 0 1 0 0 2 0 0 1 2. So we start with three variables: low, mid and high. We initialize low with 0, mid with 0 and high with n-1. And what we say that at any instant we have the following situation in our array, and the situation is somewhat like this. We have some zeros in my front, then I have some ones, and in the end I have some twos. So these are processed elements, and this is also processed, and between that I have some unknowns which are yet to be processed in my algorithm. So all the values which are from 0 to, all the values which are at index 0 to low minus 1, that is beyond low, before the index low, all the values are zeros at an instant, and all the values which are from index low to mid minus 1 are ones, and all the values which are beyond index high are twos. So we can say that initially in my given array, which is 0 1 0 0 2 0 0 1 2, initially low is at index 0, so low is at index here, mid is also at 0, and high is at index n-1. So what are the values which are from 0 to L minus 1. Basically L minus 1 will be minus 1. So initially the range is not defined and we don't have any, we have not processed any of the value in the given array. And from low to low is what, 0, and mid minus 1 will be again minus 1. So 0 to minus 1 is not a defined range. So we have not processed our ones as well. And beyond high, which is n minus 1, there is nothing. We get out of my array. So 2's are also not discovered. So what I will do now is that I traverse my array from left to right, and whenever I see 1, I do nothing. I just increment my mid index, which is m, let's say. So I just increment my variable m, or I can say pointer m. I do not do nothing but just increment my variable m. And whenever I see 0, what I'll do, I swap given value which is at index m and the value which is at index L. So what I'm saying that here I'm traversing the given array from here to here. So I saw 0. So what I'll do, I swap it with itself only. So on swapping, because m is at index 0 and L is also at index 0, so L is equal to m and is equal to 0. So swapping do not have any effect here, but we will see that effect in the coming integers. So here swapping did nothing, but and after swapping I increase my L. So here I have initially 0, m is 0, and h is, we can say 0, 1, 2, 3, 4, 5, 6, 7, 8. So h is 8. So I increment L to 1. So the window of 0 have increased from here to here, and now m is pointing to this variable. And now I saw 1, so I'll do nothing. I just increment my m, and m will now go to this variable. And now I saw 0. What I'll do, I'll swap. I will increment my. So I'll increment my this L variable to here, and swap these two values. On swapping, what I'll get 0, 0, 1, 0, 2, 0, 0, 1, 2. So here I am having L, here I am having M. On swapping, I got 0 here and 1 here. So I will increment my M again. I see 0 again. I again increment L to here and swap these values. 0 will get here and 1 will get here. Now comes the interesting part, where I have 0, 0, 1, 2, 0, 0, 1, 2. And here I am having H, here I am having M, here I am having L. So here it is 1. I'll do nothing. I'll just increment my M variable. So it will go to next. So here I have seen 2. So on seeing 2, what I'll do, I swap it with H. I swap it with my variable H. What are we saying? We are saying that all the values which are beyond index H are 2's only. So I'll swap this current H, I swap ARRM with ARRH, so that I will increase the window of 2's by 1. And that window will increase from right to left. So for that I have to do H minus minus. But before doing that I have to swap this, and I'll then decrement the H by 1. So on doing this swap, 2 will come here, 0 0 1 2 0 0 1 2, and H will point here. And for the case of 2, I'll not increment M instantly after swapping, but I'll again see what is the value which I got and it index M after swapping. So here I again got 2 and the H is pointing at here, so I again swap these two values. So on making this swap, I'll get 1 0 0 2 2. So now I am having 1 here. I'll do nothing, I'll just increment M will go here, and here I am having 0, and L was pointing to this variable. I will increment L so that I'll increase the window of zeros. So this 0 will be swapped with this one, and I'll get 0 0 0 1 1 0 2 2, and M will reach here and L will be here. So I again see 0. Whenever I see 0, I increment L is incremented, and I swap ARRM with ARRL. So on doing that swap, I will get 0 1 1 2 2. So here I have H, here I have H, second index. Here I have H, and now what happened, M has reached to H. M is also pointing to the same variable, which same integer which H is pointing. So this will be our terminating condition. I will run the while loop till M become equal to value beyond H. So now I'll code it, and so the algorithm is while M is less than is equal to H. If I see ARR M equal to 1, I'll just increment my M. Else, if I see ARR M equal to 0, I increment the window of zeros so that I have more zeros. I increment the size of window of zeros, and I swap ARR M with ARR L, so that 1 comes to the place of 0 and 0 comes to the place of 1. And also I increment my variable pointer M as well. And when I see ARR M equals to 2, in that case I swap ARRM with ARRH and increment the window of 2's by decrementing this variable. And I'll not increment the value M in this else condition, because on swapping ARRM with ARRH, we might get some different value at index M that will not be 1 for sure or not. So we have to process that value as well. That may be 0, that may be 1, or that may be 2. But in the case of 0, we are sure that here we are swapping 0 with 1 only. But here we don't know with what value I am swapping to. That might be 0, that might be 1. or that might be 2 again. So I'll keep on doing these swapping till m has got the value that is greater than h, and in the end I'll get my this beautiful array in a sorted manner. All the zeros comes at front, then ones, then twos. So you can clearly see that I am running one while loop here, and I'm not taking any extra space also. So this is the best solution, which has time complexity of big O of n and space complexity of big O of 1, which is our Dutch national flag algorithm.